Okay, so as I said, roads are banked because to increase the centripetal force in a certain car moving in a curved road. So a bank curve is designed for one specific speed called design speed. If the bank curve is icy so that there is no friction force at all, then traveling at a speed higher than the design speed means the car will slide out, up, or over the edge. So amo ra nga may design speed lang gid tanatana. So kung tamaan ka danleg, amo ra nga magwa ta na sana nga karsada. So traveling at a lower speed than the design speed means the car will slide in, down, or off the bank. When a bank curve has to be negotiated at a speed above the design speed, or if you are asked to find a maximum speed, friction is required. So the frictional force acts parallel to the road surface. The effect of banking is to tilt the normal force toward the center of curvature of the road so that the inward radial component of Fn sine theta, which is, what is that? That is the radial component of the road, which is the normal force, which is on the mass or on the weight of the car, sine the angle of banking, can supply the required centripetal force. Shooton, pwede ta naka-add on the centripetal force para nga hindi magkawas. So this one is the illustration here. So if the car is moving at a bank road, which is angled road, kami pa nakakita rin kamukang kalsada nga nagaliko nga naga-angle. Diyan sa tabay, ibuto mo dyan, nakita nyo ri nga naga-angle, tana, nagahilay ang kalsada. So here, you will see your Fn cosine theta, your normal force must be always parallel to the surface. So this one is the normal force, which is parallel to this surface. But the weight is always directed downward. And the normal force is right over here. Clear? So the normal force, which is on the x-axis, is sine theta. And the y-axis is your cosine theta. So if you have an angle theta here, your y, which is this one, is the same with this one. So definitely it is sine because it's opposite. And this one is cosine because it is adjacent. So the F sine theta can supply the required centripetal force. Right? Hmm. Ano lang to rin tana. Wait. So bank, let's now go to its derivation. So motion in a bank curve, there is no acceleration along the y-axis. As you can see in sa drawing, wala to. Kaya it's the y-axis is moving upward. So the acceleration is only in the x-axis to the sum of the forces in the y-plane. So definition, therefore, I mean, your F cosine theta is equal to F weight. Okay. Kung balikan natin to, hindi na to kayo na. Diay. Sala pag-plaster ko kakang slides. Diay. Kung tulukan natin, si F cosine theta, patas lang kay weight. Diyan, panaog padalom, they are actually extremely opposite. Okay, so they are opposite. One is moving up and one is moving down. So definitely, your normal force is equal to F weight all over cosine theta. The horizontal component of the normal force, the force the road exert against the car, provides the necessary centripetal force. Si horizontal component lang ang nagtugro kang centripetal force. Because the only force in the x-plane is the centripetal force. Kay tungod, si centripetal force is in the horizontal plane, not in the vertical. So this equation, FC, so this equation um, gives the banking angle that allows a car to travel in a curve of radius r with constant speed v and require no friction force. So here, Fc will be equal to Fn sine theta, which is the centripetal force will be equal to the x component of the normal force. So mv squared all over r, which is Fn sine theta. And mv squared over r is Fw cosine theta, as we have this equation here, this one. This one. This one here. So we have mv squared all over r is mg tangent theta, which is why we have a tangent theta. Sine over cosine is tangent. That is in the trigonometric identities. I hope that Ma'am Ramos already discussed trigonometric identities in your lesson in math. And then mv squared all over r is equal to mg tangent theta. So tangent theta is v squared all over rg, where theta is tangent raised to -1 v squared times rg. So this one now is the angle of banking. So this is the required banking angle in a certain speed. Sa speed nga to, ano dapat ang angle of banking mo? Amo lang pamangkot. So shudon, in every road that are banked, there is a required speed only. Beyond that, hindi man pwede. Mahulog ka. Or below that man also, basi makawas ikaw sa piyak na lane. Kundi nga babungguan ay kamukang sa ka-lane nga nagapaadto. Kung may paulit mo sa tagapaadto, so pwede ka mong bungay. So dapat there is only a required speed for that certain bank road. Okay. Next slide. Okay. Here. So you can see with friction, kung matangka ka friction rin, abay si friction, si FF natin, padto ay, si sum of the normal force, jay, kung matangan ta ka friction, to kay na to without friction, ha? Diyan kung si friction natin, may friction ka pa, and then may normal force ikaw nga sa X component of the weight. So, with friction, here, amo rin siyang atin nga free body diagram. So this one is your Fn sine theta, which is the y of the x component of the weight of the car. That is also, again, as I said, one of the factors na pwede natin ma-add on the centripetal. And as we all know, in the flat curve, or in the flat curve, I mean on the flat road, nga si FF dapat ang nag-provide, or the frictional force na nag-provide ka centripetal force. So kung may friction rin, si centripetal force will be FF cosine theta. Okay, because the FF is right over here, which is always parallel sa imo nga parallel sa diay sa plane damo diya ating road mo. So diya si FF padto sa dalom. So kung tirekan mo, FF must be going to this direction now. This direction, or this component of the frictional force, is only responsible for the centripetal force, which is nearer to your angle. So that's cosine theta. Okay. So what will be the case now? So because, as I said, so the effect of banking is to tilt the normal force Fn toward the center of the curvature. So the road, so that the inward radial component of Fn sine theta can supply the required centripetal force. So shudon, jata na kang si frictional force pa ang madugang. So let's hear an example. Find the centripetal force needed by a 1,020 kilogram car to make a turn of radius 40 meters at a speed of 25 kilometers per hour. So this is on a flat road. Sige lang, flat road siya. Yeah, flat road. So, kita nyo, sa flat road, uraan kita tigin gamit nga angle. I hope I have an example on the, wait, kabay pa may example ako sa, this is on the flat road. Oh. And this one now, another example. Oh, wait. Wait, Here, find the problem. Assume the road level, the minimum coefficient between the cars are perimeter. The road is level. Na siya eh. Na-discuss na rin siya. Which is available under most driving conditions. It's worth nothing. The coefficient required thus depends on the car's mass. Okay, so here, in a flat road, kung talaga natin, atin nga coefficient of friction requires here does not depend on the car's mass. Wala ta naga-depend. But only on the tire and on the road itself. But if it is angled, or if it is banked, the mass or the weight of the car matters. Okay? Nagamatter, tanan rin ang weight ng car kung nagabank. Ang mura gani nga mas nami kung nagabank ang road. So here, which is available under most driving condition. It's worth not noting that the coefficient of friction required here does not depend on the car's mass. So here, there's the formula. Sa atin una itong lesson sa flat road. Okay. So, wala na kopya ang problem. Ay maan, dapat may problem dyan mo. Wait lang, ha? Wait lang, gid. Wait lang, gid. Talaga ko na nalipatan ko lang copy ka problem. Wait lang. Hold on lang ka mo, anay. Okay naman. Okay, balik ta. Gali ay, no? Um, in question number 2, as you can see in question number 2, assuming the road is level, find the minimum coefficient of static friction, the car's tires, and the road that will permit the turn to be made. So here it discusses here if it is a flat road. Now, what if here the reaction of the force of the road on the car is perpendicular to the road bed? Since friction is not involved here, this force can be resolved into two components if it is a bank road already, which supports the weight of the car, and Fx, which avail to provide the centripetal force. I am just recalling the lesson kaina. So your Fx is F sine theta, which is the horizontal component of the reaction of the force, and Fy is F cosine theta, which is the vertical component of the reaction of the force, where theta is the angle between the road bed and the horizontal. Since Fx furnishes the centripetal force, amo rin siya, F cosine theta is just a review of our derivation. F cosine theta, so F cosine theta here is equal to mv over r. It's mv squared over r. So the vertical component of Fy of the reaction force equals the car's weight mg. And so F cosine theta is mg. So we divide the first of this equation by the second to obtain this one. F sine theta, F cosine theta is mv squared over mg, wherein tangent theta is v squared over gr. So what's the explanation of it here? The tangent of the proper banking angle, theta, varies directly with the square of its car's speed. and inversely with the radius of the curve. Okay? Again, it is directly with the square of its car speed. Shudon, kung tamaan ka gamay ang radius na, dapat there, and inversely with the radius of the curve. So kung gamay ang radius na, dapat pabahilan ang ana nga angle of banking para at least pwede ko kapadasig. Damo kara. So the mass of the car does not matter when a car goes around the curve at a precisely designed speed. The reaction force of the road provides a centripetal force. Here, if it is a flat road, wherein exactly ang imo nga speed gingamit is for that design for that road. Ay may specific speed ang that road. If the car goes more slowly than this, friction tends to keep it from sliding down the inclined roadway. If the car goes faster, the friction tends to keep it from skidding outward. So the same consideration applies to an airplane making a turn, in which case specifies the angle its wing should make with the horizontal. Amo man ako magliko ang eroplano. So ang mga eroplano natin dapat may angle man tana magliko to require a certain speed. Okay? So that's the case of banking road. So liwatan natin. In a banking road, or in a road which is moving in a circular path, there is tawag ka dyan, a provide speed for every object or every car to move at a certain road. But then, because we want to have a better road that we could increase our speed, roads are banked. Engineers, I mean, bank the road so that we could increase the amount of speed that we are going to travel or to move along a curved path. Now, in moving at that certain speed, the tendency of a certain object to move class or the centripetal force depends on the horizontal component of the weight or the normal force of the object or the car. Okay, that is in frictionless. But because if we are consider friction, friction is another point that could add on the centripetal force. So I'll give an example. Kadya lagi, maubra ko, picturean ko ang problem kadya. Then isolve ninyo, no? Isolve nyo. Tawan ka mo kang 20 minutes to solve. And then, ma-meet up kita after 20 minutes. Okay? Ma-meet up after 20 minutes. Okay. Escape ko dyan ay ipasa ko rin dyan sa atin nga ano, GC.